Hello everyone, my name is Sean Oliquer, and my final project is on graph algorithms and machine learning with graph neural networks. So the problem statement that I'm really looking to solve and explore in this final project is really how can I leverage PyTorch Geometric, which is a specific Python package utilizing PyTorch, and how can I leverage the graph neural networks that it contains and houses to assist in predicting which categories specific research papers belong to. So it's a little bit of an exploration into new technology, something that I haven't worked with, graph neural networks, but also how can I leverage that to enhance current capabilities such as classification. So the data set that we're actually pulling out is from OGB, the Open Graph Benchmark, and it's a group within Stanford that is trying to push graph neural networks forward. So they have open sourced, readily available big data sets specifically for working with graphs. Right, we have 10 or 100,000 to 10 million nodes and edges. Right, so that is very, very big data. And just kind of a very, very high level, graph neural networks are neural networks designed to work on graph data, right? So if we generalize the nodes and relationships between any data that we input, graph neural networks are just very extensible or generalized neural networks that allow us to train those models. And if we go through the notebook here, right, we import our relative imports here. Highly recommend installing CUDA. Here is just a quick visualization of something like it's a t-SNE reduced dimensionality version of our data frame, but we get something that looks like this. So very, very big data, right? If we imagine all of these connections between all of these nodes, that's quickly going to blow up. Right, so we have 169,000 nodes, just over 2 million edges, and 40 classes, and that's what we're going to try to predict on. This get index split is a method that splits our data into training, validation, and test. We're going to inherit this Sage class from PyTorch Geometric, and we're going to modify that and use that throughout. We define a training and a testing function, and then we iterate over our epochs, which in this case is 200. And we get somewhere around 70%. We're saving our model, and then we plot a confusion matrix at the end. Thank you.